We had a great product, but unfortunately, it didn't make it. We didn't do it in the beta. But I remember when I was coming back up from LA to Seattle, I had chatted with Adam, the CTO here, and I actually wrote this Adam is. And Adam's a good friend. And the week I moved back up, he took me out to lunch and said, "Why didn't you tell me that you wanted to come back to Seattle? Why did you tell me that you were done at the last gig you're at?" And I was like, "Well, man, I want to make small games. Like the last thing I did was work on a giant game, and I'm kind of tired of working on giant games. I want to work on small games." So I had to do that. I had to get it out of my system. So when I was done making that small game, I messaged Adam and said, "Hey, what do you got going on? What are you doing?" I still used Chef every day. The entirety of the game that I had built was automated fully with Chef. We used Burp Shelf and the environment cookbook pattern, and all the things that I had been leading up to. Right? We got like 90% of the way there, 95% of the way there. We had a number of server programs that knew how it all worked, and it was good. So Adam said, "I've got this great idea. I think you're really going to love it. It kind of inverts the way that you had been thinking about doing development." So that sounds great. Tell me a little bit more. And the idea was this thing called Builder. That's why the build service is called Builder. That was originally the name of the Habitat project, though. And it had no vowels. It was BLDR. So if you visit bldr.habitat.sh, that's now why that's the build services URL. So call back to Adam's prototype. And he said, "You can come and you'll work with Fletcher and me, and we're going to build this thing." And I was really hyped on it. But I said, "Okay, this clicker's not working." There it is, nailed it. And I said, "That's great, but there's some things that this project needs for it to succeed." I had just worked on a game, and while my trade is a network programmer, I also fancy myself as a designer, specifically a game designer, but games are very similar to products. It's just a product in the end. And because I had been trying to solve this automation infrastructure automation problem for so many years, I felt that there was some key things missing, just like there was some key things missing from that game that I had built that we couldn't get out of beta. And they were these things that you see on the screen behind me. Whatever this project is, it has to work on any infrastructure. It can't just be for containers. It can't just be for VMs. It has to work on physical hardware, VMs, and containers. And it has to work with every application. You can't tell people to rewrite their application. No one's got time for that. And if they do, you're only going to be able to go after a certain part of the market, and you're only going to be able to please a small subset of customers. So it has to be greenfield and brownfield applications. The other is that it has to be cross-platform. If anyone here used Chef in the beginning, it was not cross-platform. The Windows support didn't happen for a while, and it was mostly driven by the community in the beginning, if I recall. So it has to work on Linux, it has to work on Windows, and I want it to work on Mac so badly as well. But definitely Linux and definitely Windows, because that's the large portion of your server infrastructure. And the last one is, and this is the most important to me, that you must be able to learn this in a time frame where you can measure it in lunch breaks. The number that we've got in our head right now is 80 minutes and not 80 hours. You have to be able to learn how Habitat works in 80 minutes or less, which is typically maybe 2 lunch breaks. Or for me, it's like a half a lunch break, Just a little bit of an 80-minute break. But that's super key. So the idea that we had, which was Builder, came to fruition in 3 pieces. The first thing we did was we built 2 of them, though. We built a package manager and we built a supervisor. I never thought, ever, that I would build that first one. And I was like, maybe if I'm feeling cool, I'll build that second one. But just to give you an idea, to build a package manager, what it means is that you rebuilt a Linux distribution. And there's a couple things you never do. Is roll your own crypto and build your own Linux distribution. And at the time, so I had worked with a guy named Patrick Wyatt for a number of years, and I consider him the biggest influence in my life. He brought me into a company that I worked at called ArenaNet. Was the guy that gave me my first actual programming job. He's also the lead engineer of Warcraft and Starcraft and Diablo, and he taught me to be a server programmer. I told him about this idea. I had worked with him for a number of years, and I had that game that I was building last. I had worked with it. I told him what we were doing. He was like, "You are stupid." he said, "Why would you do that? You're not listening to anything I've ever told you to do. You're breaking one of the two rules that you never do." And I said, "Well, I really believe that we have to do this to be able to have the other thing that we want to build, which is the supervisor. The supervisor that we have with Habitat is it's just a process supervisor, but it has a key component in it that's different than other things like System D or running. It has a gossip layer. It's a networked supervisor. It gossips information through a ring, and we're going to talk about that in this chat here. And the last bit that we built is a build service, and we'll get to why we built that. In the beginning, we didn't know we needed it really, and then it became pretty apparent once we stood up the other things. And this is pretty cool. Like the whole way that we built Habitat has been based off of starting with an idea, building on top of it, and really developing out of needs, or solving needs. So let's talk about first the packaging system and why we thought we needed to do this. The principles of our packaging system, or any packaging that you should be using, be it a container or whatever, is that every artifact that comes out of your build system has to be isolated, it has to be atomic, and it has to be immutable. Those learnings came from using Chef for 8 years, or whatever it was. You don't want runtime problems. You don't want convergence time problems. You want every problem to be solved at build time. And with these three things, these three principles, you basically get one of the superpowers of containers without using containers. That doesn't mean containers aren't good and they're not worth using. It just means that we can extend the power of containers back to VMs or physical hardware. And that brings me to that first point, which was it has to run on any infrastructure. Check one, right? Another thing is that to represent these packages, it has to be in easy language, which fits into that 80 minutes. We use your system's language to represent these packages. So Bash, or if you're on Windows, PowerShell. You don't need to learn a programming language. I mean, technically Bash is a programming language, but really? Like, is it? It's pretty easy, dude. Unless you want to do like for loop. Or like check a variable set. Or really anything other than doing system commands. But by the way, I promise you, one of the number one things that I get asked is like, why did you decide to use Bash? And I tell them I didn't choose that. Somebody else did, and I didn't want to do it. I wanted to write it all in Lua, and I'm a game programmer, and it actually is the right choice. And I promise you, if you spend a little bit of time learn Bash, it does not take a long time. And I'm talking to a room probably full of people that know Bash already. And I'm the one guy that was like, I'm to learn Bash? Come on. But it makes it a lot easier. The next bit is the supervisor and the principles of that. The principles of the runtime. So the supervisor, what makes it special is that it's reactive. When one connects to the other, it tells the other about itself. And when another joins, it finds out about each other. I remember that I had an interview at the company that I was at just before, the one that had the failed game that I was telling you about. And in it, they asked me, this is like 2012, they were like, hey, you're a big Chef user. It's before ChefConf ever happened, so it might have been 2011. They said, what would you change about Chef? And I said, well, it's not reactive in any way. Everything is top-down. You have to micro everything. It's basically orchestration. And I even tried to build an orchestrator, even though the words that were coming out of my mouth were telling me to never do that. And everyone made that mistake because we really thought that's how we solved this problem. But this was the key component to Adam's prototype and why we built everything in service of this, of the runtime. So I'm mostly going to cover the runtime here to show you the power of this. The runtime is, it's a process supervisor. It takes those packages we just built, it turns them into services. The services interconnect. They gossip, they react to each other, they auto-configure based off of each other. They do rolling updates. They figure out who's the leader and who are the followers. We map this. We auto-configure things based on, or allow you to describe very common patterns that you would normally see in application development. And most importantly, each process or each package that turns into a service is completely isolated from everything else, from build time and runtime. So when we start a process up, it does not share environment variables with anything else. It doesn't know about any of the processes of the machine. It is completely isolated. And like I said, those three things are extremely important to having a reliable deployment pipeline. So I'm going to take a quick segue here and tell you about a story about the day we rebuilt the world. This CVE number, you should just memorize it. No, I'm just kidding. But it happened in 2002. This is the day that zlib had a double free error, a double free vulnerability in it. Zlib is a compression library. It's the basis of almost every piece of software in Linux. People were taking zlib so used that people would take it and statically link it to their application, or they would distribute their own dynamically linked, like DLL or SO with it as well. And the thing is that when this vulnerability was found, it allowed for remote or local execution of arbitrary code on any machine. I don't mean any machine like in your infrastructure, you got 20 machines running. I mean every machine. We had to rebuild the world because of this vulnerability. And luckily, there was less computers in 2002 than there are today. Right now, I have a fucking computer on my wrist. You know what I mean? Like, everyone has a computer in their pocket. This guy's got 4 computers. I had just right there. He's got a bunch, like, it was everything. And the problem with this is that it's not automatic. So we talk about vulnerabilities all the time. This was 2002, and it was a particularly bad vulnerability, right? WannaCry just happened, right? We talked about that today in the demo that we gave in the keynote. Heartbleed and OpenSSL or shell shock. These vulnerabilities keep popping up because, unfortunately, systems programming isn't safe unless you're using Rust. Small plot. Rust is great. So remember I said Habitat is these 3 pieces. This is why we built Builder. So we have that supervisor, we have the packaging system, and what we realized was we were repeating the same mistakes that people were making in 2002, which is basically the way our packaging system works and why it's reliable is we do a form of like weird dynamic static linking. We dynamically link everything, but you can only ever dynamically link to one thing. And the one thing you dynamically link to is the thing that you built at runtime, built at build time. You can never accidentally link to a piece of software you never intended to. The problem with that is if you want to upgrade your software or if you find a vulnerability in OpenSSL, it's not going to upgrade underneath the hood. You need to rebuild your whole application to make sure that you link to the new version of OpenSSL. So you don't have to look at this graph behind the words, but this is the architecture of Builder, and this is why we had to build this distributed build system. The point of it is that it performs dependent builds. That is, if we rebuild OpenSSL, you will eventually have your application automatically rebuilt because it will see that OpenSSL was built, and its dependents have been rebuilt. Dependent is, so it's not your dependency, it's the thing above you, and then so on and so on. And eventually, your application gets rebuilt. And what this eventually turns into is you coming in the morning because a vulnerability came out, and you see that your acceptance environment was updated. And you're like, oh, what happened? And you go look, and you see that there was a massive vulnerability last night. It was identified by your upstream. You patched it out, and your acceptance environment was automatically updated with your app. And you see that, and you say, great, we're going to promote that to production. This is great. This looks perfect. And you didn't have to do any work. I remember when Heartbleed came out, and we had a couple engineers work to fix that problem over a couple-week period. That was bullshit. This scenario that we're now talking about is you were sleeping, and you came in, and it was fixed. So that's, anyway, we build out of demand and need, and that's why we built this. This is the application rebuild flow, how it works. So basically, builder requests a new build of your application. We'll say it's open SSL this time. Once it rebuilds, it publishes it to the depot. The depot is an artifact storage. It has release channels as well. So it holds on to things like Artifactory or an equivalent. And it puts them in an unstable channel or a stable channel, or you can name it whatever you want. So like for us, we have unstable connected to acceptance, and we have stable connected to live. Those are our only two environments right now. Builder's self-hosted, by the way. So Habitat runs Builder, Builder builds Builder, and Builder builds Habitat. And Habitat, the supervisor, updates from the depot that it's running. And then the supervisor gets auto-updated, and then the builder gets auto-updated. And you know, my brain just broke too. But it's cool. So depot gets updated. Supervisors elect an update leader. They pull out of the depot. They coordinate who updates first. It's never the topology leader. And they just go in a ring, and when they're done, they say, yeah, I'm all updated. We talked about release channels as well. So you have software that's automatically been put in acceptance. And in this diagram, you see that V1 is currently in dev. Well, we want to put it in acceptance, we promote it into the acceptance channel. And then the acceptance supervisors pick it up, and now they're running it. And if you want V2 in production, you promote it, and now it's in production. So that's the basis of how Habitat works. Today, I want to go through an exercise, though. I want to show you guys how to run a multi-tier application in Habitat. The first thing that you're going to need is the Habitat CLI. This is the main entry point. Everything that we build off of Habitat comes with a CLI, or it's a subcomponent of the CLI. You can get it really easily just by filling this installation script. And I actually forgot to set up that URL before I came on the stage, so
we'll do later.
I'm going to do that later. Anyone watching online, this will be set up. Installation is easy. The next thing that we do is we go into our development environment, which is called the studio. And this is where I begin my live demo, which I haven't done one since 2013 for a very good reason. I'm very bad at live demos, so you're welcome. All right, can everyone see this? Everyone here? How's that? What's it look like? Good?
Kind of dark, but that's what it is.
You don't need to see the word master, it doesn't matter.
We have pretty colors though, so it might be okay.
All right. Make this window a little bit bigger. Like I said, a lot of demo skills. Appreciate it. All right, so the first thing you do is just enter the studio. The hat binary is, it works on Mac, Linux, and Windows. Windows we're still working on, but basically works. Okay, we're going to get in here, and what we're going to do is, I mentioned that Builder runs Builder. So what we're going to do is we're going to install the router, and we're going to install the API server. What those things are, don't worry, the architecture's up there, but these are two components. Gateway is what you make it connect to, the router is how we get messages throughout the system. Another like tidbit here is that Builder is actually an MMO backend. That's the only thing I have to make apparently, so that's what you guys got. All right, these are the two packages that I need because I'm going to start both of those in this VM. Next thing we're going to do is we're going to load up the router. So when you enter a studio, there's a supervisor running in the the background already. If I enter a studio, I could suggest that it doesn't, but for right now, these purposes, when we logged into the studio, it gave us some helpful output as well that just told us that the supervisor was running. So let's see that router. It is running. Yeah, we're running. It's that version. It's up. It's been up for that long. Tells us it's good. A little bit more information there as well. So let's see what we can configure on this router. All right, looks like we can configure a client port, something called a heartbeat port, and a listen address. So let's see if the client port, if anything is listening. No, that's that. Why is that? Oh, right. So we're in the studio. There's nothing in this. There's not a single thing running in the studio right now. There's no software. This is called BusyBox, or specifically it's BusyBox, but it's a stripped down Linux. We're in a jail right now. There's no other software in here other than Habitat and whatever I tell it to happen there. This is so we don't accidentally link to any software that we didn't intend to link to when we build software. So to get netstat to see if this port is listening, all we do is figure out, hey, what provides netstat? And it's going to tell me that this binary or this package is box static has it. So I'm going to go ahead and install that. Then I'm going to run netstat. And I still don't have it. That's because I have to put the binaries that is installed in my path. I can do that with have package binlink BusyBox static. Now look at that. I got netstat. I should figure out what that port is again. I wrote this cipher. Why do I not do that? Because I'm on stage. All right, cool, it's listening. Excellent. So we have it running. If I check the logs as well, in the studio, you can type SL, and it will bring up the supervisor's logs, supervisor log, right? It shows me that the supervisor started, and also the router is started, and it's listening. So let's go ahead and start another supervisor up with another router and connect it. So the services connect to each other, and they gossip information with each other and figure out about each other. This is how we do that. One thing that I'm going to show you is that you can configure your studio when you turn it on and put some information. And one of the things that I've done is ask this studio to not start a supervisor. The reason for that is I want to connect it to another supervisor that's running. And I happen to know the IP address of it. I don't, so I'm actually going to make sure. All right, I'm glad it's a different IP. Excellent. So go ahead and get the router. And what we're going to do is now start it. Thank you so much. So that's what I want to do. First, I want to start up the supervisor. So you can't load any services until you start the supervisor, basically.
You can do a soup dash run, it'll background it.
So in the studio, Fletcher just signaled to me that he added a pretty cool command that I didn't know about this yet, because it happened a day ago. If I run sub-run with the peer flag.
You try it out.
It just started in background. Why don't you come up here and give this presentation with me, man? This is helpful. It started in the supervisor, and it connected it to the other one. So now what we're going to do is load up the router as expected in that group. Yeah, here it is working. So if I check the logs, we'll see that it's coming up, and we're good to go. We're going to go back to the slides real quick. We're going to chat about service groups. So service groups, you saw me pass this flag, dash group, and it said acceptance. Service groups are an identifier. Every service that starts joins a service group by default. It'll join the service's name, so in this case, builder-router, the group name, which if you didn't give one, it's default, and then an optional organization name, and that's that @ sign afterwards. So I just started builder.acceptance. Here's some examples of service groups. So there's builder-router default, builder-router acceptance, or builder-router acceptance at Chef. Those are all valid service groups. When we talk about a service group, that's this thing in the ring. So in this diagram, all the way to the left, you see supervisors with this kind of like circular data flow, right? And you see services hanging off of them. Every service in there is part of a group, and everything in a ring communicates to each other. But they don't know about each other. This is that isolation. Services only know about everything within their own group unless you perform a special operation called a bind. So all those routers that I just started know about each other by default. If I were to look at their configurations, both of them have auto-configured to talk to each other, and they started, the routers in our infrastructure of Builder are fully meshed, which means that everyone knows about everybody. If you wanted a service to know about another service, you have to use something called binding. And the way that you do that is inside of the plan, which is the definition into this, and we'll get to that in a minute. You say that I expect that I'm going to connect to a database, or I'm going to connect to something else, right? And I wanted to expose a port. It has to be this shape, is basically what you're saying. And then the database, so in this case, on this slide, we have MySQL or Redis. It says, I expose this shape. And when I designed this feature, the way that I thought about it was that ridiculous, I was literally in Amsterdam, so I had this ridiculous like plug that would take any kind of, it's a socket, right, that plugs into a plug, that takes any kind of power adapter I had, and I could plug it in, and I was like, this is a pretty cool polymorphic relationship they've defined for me here. Oh, cool, we can use that for services. So polymorphic relationships, all that really means is that I don't care what you are, I just care that it basically looks like I fit. Basically, it's if I fits, I sits, you know, like a cat. Noah? Great job. Nailed it. That guy raised his hand. For the audience watching, the mic, the online audience, they're not mic'd. You can't hear their laughter right now. There we go. Thank you. I pulled it out again. Let's go back to the live demo. I'll beg for laughs later. All right, so what we have to do now is reload the router that we originally started. We have to do that because when we started it was in the default group. So those routers, although I started them, they don't know about each other because while they're both routers, they're not in the same service group. So to do that, it's the same command that we had started. Group acceptance, and we're going to call force, which is a reload basically. And we'll see the log that it gracefully terminated, it started back up, and now they should be connected to each other. Check the status, and we're good. So every supervisor exposes this thing called an HTTP gateway. This is an HTTP server that runs on every single supervisor. You can query it to figure out what services are running, the state of the ring, the state of service groups, the configuration of every service as well. It's generally just a useful port that you can communicate to. So what we're going to want to do is install some curl here. And if I pass the -B flag, that's the same thing as the bin link that I did earlier. So this is automatically in my path now. And I also want this tool called JQ, which allows me to format nicely JSON objects. So let's see what's running. So supervisor always runs on port 9631. And I'm going to ask it about build a router acceptance.
Is there a package repository that you're pulling this from?
What'd you say?
Is there a package repository that you're pulling this from?
The question was, is there a package repository that I'm pulling these from? Yes, every package that I've installed so far came from the public depot. So Builder that's running in production right now, if you see me run package install, and of course I'll be run package install, when you saw me do that, it pulled it from the public depot. So by calling this endpoint, I can see a bunch of information about that service that I started up. So this is just a giant JSON object of that service. Specifically though, I can also ask for just its configuration. And that's what I want to see right now. So right now, it's configured that port, 5562, and the heartbeat port is 5562. There's another bit that I can curl from here as well. And unfortunately, there's so much data, it's hard to fit on the slide. I'm really just showing this to you guys, you go play with it yourself and see what it does. But if I curl for something called the census, there's a lot of information here. It's basically debug information about what is happening in the ring. You can get a lot of info from here. It'll tell you about elections that are happening, leader elections, update elections, members that are dead, members that are alive, confirmed dead, confirmed dead. I said that twice. They're really dead, I guess. A lot of debug information. And that census, what that represents is something called the service ring, which, if we come back to this slide, we see the supervisors connected to each other. They're gossiping information. Service groups are talking to each other. And that is what we mean when we talk about the ring. So if you talk about the census, a census is members within a ring. And the ring is just a bunch of supervisors with a bunch of service groups that are sharing information with each other. So that's basics of the runtime. How do you use this? Let's go back to the lab demo. Sorry, guys. So knowing what the ring is, how do you use this? What is it? Why is it useful that they're so reactive? Well, one of the things that we can do is configure services that are in that ring by asking them to, you say, I'd like you to be configured this way. And they just kind of figure it out, and they'll gossip that information amongst each other. So what we're first going to do here is we're going to start another service, and we're going to bind it to the routers. So this flag, when I went to the service binds slide a little bit ago, this is the representation. This is how you leverage those binds. So I know that the routers expose what I need. And I know that when I build this API, that they'll fit that socket. The plug of the API will fit the socket of the router. And what I do is give it a generic name. The API decided that it's going to call this thing router. And it binds to a service group. So by running this, if we look inside of the log, we now see that the Builder API server has started and immediately started doing some health checks. So it's now connected to both of the routers. It knows that because the supervisors communicated the information to it. So if I were to cat the config file of this API server, you'll see that there's routers in it and a bunch of other information as well, which it just auto-discovered. So what I want to do next is I want to apply some configuration to the router. And I want to see if the API server picks it up. So let's quickly again check. we can configure. Okay, client port, let's change the client port. Let's just change it to 5,000. And let's apply this configuration to that service group. Syntax here is the group that I want to apply it to. The number that you see there is the incarnation, which is like a monotomically increasing number that defines the version. And then the last bit is the file or the contents of the thing that I want to configure. When I run that, it's going to apply it. And now if I curl for the config of that router, I should see now that the client port is 5,000. And if I cat the config, I can see that it's connected to that router at 5,000. I usually fail horribly at live demos, by the way. So, I'm so I know this works. Like Builder and Live is using this. But right now, this is the bigger moment to be watching this. Okay. Let's go back to the slides. I'm going to have this, just in case it decides to break. All right, so like, how do you use that? What do you do to leverage this yourself? How does the packaging system work? That is the on-ramp. What we've designed recently, so we've had a packaging system for a while. If anyone's touched Builder, you've seen it. It's a shell script, plan.sh is what we call it. That's the entry point. Recently, we've been working on a feature called scaffolding. Scaffolding is our way to reduce the on-ramp size, to reduce the taxes you pay, to being able to use the thing that I just showed you. If we go back to my earlier statement about me even coming to work on this project, it was 80 minutes, not 80 hours. It was learn this in lunch breaks. One of the things that we found was, I mean, even last year, the talks that we gave largely were about how to use plans, how to build your software. We didn't even really tell you about the supervisor a whole lot because it was a big tax to pay. We had a lot to tell you about. Well, recently, from the great work of Fletcher and Ryan Hess and a number of other people on the team, they were able to make the abstraction correct. And we have this tool that we now have called scaffolding. And what it does is it abstracts what those plans look like for various languages or runtimes. You can think of them like equivalent to a Roku build pack if you've ever used Roku. And one of the things that I very much want to do is make this as easy to use for any developer. Habitat is primarily a developer tool. Yes, you can definitely use it if you're an operator. And yes, if you're a DevOps person and you're in the middle between the two, you can totally use it too. But I think that if you get the abstraction right for developers and you allow them to learn it in a couple lunch breaks, even if you're an operations person in this room right now, it'll be so much easier to get them on board to use this thing. And by going to where they are, going to the developer party, going and saying, you have a Ruby app, cool, I have a scaffolding for you. You can use this, and you'll instantly be able to build and run your software. That will get us to the place that we need to be at. I've got more to say on this, but first, I want to show you one more piece of a live demo, and if this one works, then I'm going to go get drunk. I don't want to have any more like this. So what I have here is a pre-built Rails application. It's called Habitat Life. If you look at the plan of it, this was just generated just before I came on stage. There's a plan called Have Plan in it that you can use. We're making some improvements to that command as well. It'll automatically figure out what the source code in your directory represents. So it'll give you some choices. Be like, I think you've got a Ruby app, is that right? I think you have a Node app, is that right? In this case, we have a Ruby, we have a Rails app. This is what we got. So I'm already in a studio. This is how you represent a plan to run a Rails app as is right now. It's 5 lines. It used to be like 80. This abstraction allows it to be 5. So I'm going to run build. Build just said in this spam that it detected it was a Rails 5 app. It also detected that it had Postgres as its backend. It also detected that it had no Nogiri. So you don't have to fuck around with building over here. You just figure out how to build it.
Yeah.
Anyway, it's just going ahead and it's building that entire package for you with 5 lines. It knows how to exactly build a Rails application. This is the abstraction that I'm talking about. This is going to the developer party. We have a scaffolding right now for Ruby, which includes Rails apps. For Node, we have one coming out for Go. We have one coming out for Python. We want to work on one for Java. The goal here is to work on one for every runtime that you all have. Even there will be one for Rust, whenever I feel like rage hacking that one out. Yeah, we want to continue to grow this ecosystem of scaffolding. Yeah, so finished. And if I started that up, it would work just like the other services as well. So what I didn't cover yet, or if you wanted any additional details, you can head over to our tutorials. We are doing a refresh on these, and we hope to have them done by ChefConf, but unfortunately, we had too much to do. But they're pretty good that they are right now. You can see details about everything I went over this talk right now. This is the beginning Habitat talk. This is the first 40 minutes of hopefully the only 80 minutes you'll ever spend learning Habitat. There's another talk that's coming up as well that Fletcher's giving. Fletcher's going to talk more about security. When I configured that, what if it was a password? So there's encryption among secrets, among passwords or configuration data, right? He's going to talk about rolling updates. So I didn't show you about any of the updating things. I just showed you the configuration apply, right? So how updates are orchestrated. He's going to show you about leader election. So if you have a database server that has a leader and some followers, we have it built into the runtime. There's a lot of great information that's about using Habitat in production, and that's Fletcher's talk, which is at 2:30. Next one. I encourage everyone to go there. And if you're watching online right now, please stay on the channel and watch the next video. I hope that you can learn how to use Habitat completely just by watching these 2 videos, and please enjoy your lunch. Habitat is also the most open project that we've had at Chef. Our project tracker and our roadmap are both public. This is a screenshot of our roadmap. This tells you what we are currently working on, in the near term what we're going to work on, and in the future what we're working on. You can also make suggestions to this. This project is for us, and by that, it's because we're making it as open as possible. Like I said, our project tracker is also open. You can see every issue that any one of the developers is working on. And we also have 2 or 3 core members, which they don't work at Chef. They just like working with us, they like the project, and we are very welcoming to anybody that's also interested in working. If you want to be a core contributor, get involved, come into Slack, our community Slack, start chatting with us. If you have questions too, and you don't want to contribute, it's okay. Feedback is super appreciated. You find a bug, let us know. No one's mad when you find a bug. That is how it gets better. And if you all want to contact me online, I'm JD Winsor again. You can find me on Twitter or GitHub. That's it. Thank you everyone so much for coming and listening. And please follow up with Fletcher's chat next.